All right, ladies and gentlemen, this is going to be hopefully a quicker one, but we got to talk about what that means when the exponent is a fraction. So that's the main focus here, because the last video kind of went over what's this called. It's called a radicand, and it actually reminds us down here. And this tells you what root or how many numbers that or how many of the same number we're trying to find that multiply up to what's called the radicand. So this we should be able to do. As a matter of fact, you should, if you got a calculator, it's even easier. But a few rules here tells us that, hey, this and this mean my final answer is going to be negative. Now I got to take and find 4 and 2 and 2 and 2. I've got 3 2s. I needed 3 of them. So put those together. My final answer is -2. So the cube root of -8 is -2. Now for B, this being on the outside of my radical, again, kind of a shortcut way to sit there and say, hey, your final answer is going to be negative. So I'm just going to write it, and then I'm going to work the problem as it was. Now, technically, I don't have to. I already did, but I'm going to write it just for practice. I have 3 2s. That 3 told me how many 2s I needed, or whatever number I needed, how many times. Put them together. So the cube root of -8 and the negative cube root of 8 are the same answer. Notice how this is that on B, the answer is not plus or minus 2. The answer is -2 because the negative on the outside originally told us that we want the negative answer. Now here on A, we had to have a negative answer because our radicand was negative and our root was odd. But let's look at 16 and try and figure out what in the world this is telling us. And there is a little bit of a shortcut here. Our notation, anytime you have a fraction, okay, what it means is you turn your fraction into a radical, and whatever the denominator is going to become your root. And then you just take your base, 16, and put it in because that's your radicand. So really, 16 to the 4th, which I'm going to erase all the marks I put there so you can see it. 16 to the 4th is the same thing as saying the 4th root of 16. Now, if you go back and you look at the previous video for example 1, we know this is 8 and 2, and the answer is going to be 2. But here's kind of my proof or my work. I have 4 2s and I needed 4 of them, so my answer is 2. But my answer is actually plus or minus 2. Now, I'm looking back at my notes to verify. Yep, that's what I thought. They don't, this is what I was thinking in the last example, so I was mixing them up, and I did read them, and I was starting to mix them up again, so I was looking at my notes to make sure. Because this is an assumed positive right here, I only want to use the positive for my final answer, so my final answer is 2. Now we can move on to D, because this C is the same kind of problem as A. The positive or the negative is inside of the radical. I'm shaking the desk this time. What happens when you have the negative this was the same thing as B. The positive and negative is outside because this 1/4 belongs to the 16. But what happens when it's the inside the radical? So this problem right here, I'm going to put it in green. This problem is the same thing as take the 4 with the radical and put the -16 inside. So in this case, we find that we can't get an answer. the reason is I know it's got to be 2 times 2 times 2 times 2, or negative 2 times negative 2 times negative 2 times negative 2. The problem is I have a negative times a negative times a negative times a negative, 4 negatives. Well, 2 make a positive, so 2 more make another positive. So in reality, I have a positive answer. I can't get a negative answer because my root is even. So this one actually has no answer. Now, I don't want to mix it up with the idea of the negative being on the outside. This only occurred because our group that's being taken to the 1/4 power was negative. If that negative had been outside of the group, we would have been fine. But because it's part of the radicand itself, can't do it.